Welcome back, children. As we have learned Sn in AP, sum of n terms, right? We have formula over there also. Likewise, on the same lines, we have Sn in GP also. So, sum of n terms of geometric progression. Now, in AP, we never had any cases as such, right? We directly had formula of Sn, n by 2, 2a plus n minus 1d, or n by 2, t1 plus tn. But in GP, we have three cases. Now, why these three cases are? What makes these three cases to come into existence? On what parameters Sn is judged on? The answer is Sn, we have different formulas for Sn depending upon the value of R. Now, we all are aware what is R? Common ratio. Common ratio, R. Now, here, what happens when we say common ratio? R could be greater than 1 or R could be less than 1. Based on that criteria, or equal to 1 also. Those who feel that, sir, why you missed out R equal to 1? So, R is less than 1, R greater than 1, R equal to 1. Based on that three or those three values of R, we have three cases in GP, whereby which we say case 1, when modulus of R or absolute value of R is greater than 1, then the formula for Sn is this. When modulus or absolute value of R is less than 1, then the formula is this. When R is equals to 1, then Sn is. Now the question arises, sir, why we are making use of mod R, absolute value of R? What makes us write down mod R or absolute value of R? So before learning this, by hearting this formula, let's focus on the small note which is being provided to you. What if is R common ratio, as we are aware, what if R is negative? So at times when we have sequence of GP, the ratio turns out to be negative, right? Say minus 18 by 6, answer is minus 3, that's what I have taken. So what if R is minus 3? Now those who feel that minus 3 is less than 1, minus 3 is less than 1, no children, that's the reason we have written. Then what is mod of minus, what is mod of minus 3? Mod of minus 3 or absolute value of minus 3 is 3. So earlier I was thinking that this to be less than 1, but when I calculate the absolute value, it is greater than 1. So here mod of R is greater than 1 or absolute value of R is greater than 1. Likewise, we have common ratio in fraction also, right? We have studied. So now if R is minus 1 by 3, then modulus of R is 1 by 3. Again, mod of R is less than 1. Now why I say less than 1? 1 by 3 is 0.333. So come what may, one has to keep this much in mind, that whether my R is negative or positive, mod R is always going to be positive. Mod R is always going to be positive. Even for that matter, my R is negative, modulus of R is always positive, absolute value of R is always positive. So mod R should be greater than 1 or mod R will be less than 1. Are you getting me? It can be less than 1 only and only when R is in fraction, numerator is smaller than the denominator. And greater than 1 if it's positive value, or even in fraction, but numerator will be greater than denominator. Right, children? So now we have understood what is R, mod R greater than 1, mod R less than 1. What if mod R is equals to 1? But prior to that, case 1. When modulus of R is greater than 1, the formula for Sn is A R raised to n minus 1 upon R minus 1. Let's by heart it right now. We are not here to derive all those formulas. What is Sn formula for R greater than 1? For R greater than 1, A R raised to n minus 1 upon R minus 1. Once again, Sn is A R raised to n minus 1 upon R minus 1. What if mod R is less than 1? Sn is A 1 minus R raised to n upon 1 minus R. You just have to flip this. R raised to n minus 1, here 1 minus R raised to n. Here it is R minus 1, 1 minus R. What if R is equals to 1? Sn is equals to n times A. Sn is equals to n times A, right? What if R is equals to 1? The formula for Sn turns out to be n times A. We have to keep only one thing in mind. Whatever is R, mod R is going to be positive. If R is positive, we need not write down this modulus sign in our question. We'll write down our modulus sign in our answers only and only when we get R negative. If we have R positive, we will not write down mod R. By default it is said. Right, children? kindly by heart these before we start any sum of Sn. Sure.